Gay-Lussac's law. Gay-Lussac's law is a gas law which states that the pressure exerted by a gas or of a given mass and kept at a constant volume varies directly with the absolute temperature of the gas. In other words, the pressure exerted by a gas is proportional to the temperature of a gas when the mass is fixed and volume is constant.
This law was formulated by the French chemist Joseph Gay-Lussac in the year 1808. The mathematical expression of Gay-Lussac's law can be written as follows, where P is the pressure exerted by the gas, T is the absolute temperature of the gas, and K is a constant. So we have here a plate, match, candle, food coloring, water, and a glass.
First, we are going to get the candle and light them up with a match. Next, put the candle on the center of the plate. Next, fill the plate with a leach of water and food coloring to make it easier to see. And last, take the glass, placing it over to the top of the candle. After how many seconds, when having our glass over the candle, you will see that the candle's flame is getting smaller and smaller until they are extinguished. Also, you will see that the water level underneath the glass begins to rise after the light from the candle have been fully extinguished. You will also notice that the water outside of the glass is lower than the water inside the glass.
So our conclusion to our experiment using Gay-Lussac's law state that temperature and pressure are directly proportional given the equation as P1 over T1 is equal to P2 over T2. When the candle was lit up, the temperature increased, making the gas particles move faster, which led to an increase in pressure. When the candle flame slowly extinguished, the temperature decreased, making the gas particles slower and the pressure decreasing as well.
For us to be able to understand Gay-Lussac's law, you have to be familiarized the formula and how to solve it. So here's some example on how to solve the problem using the formula of Gay-Lussac's law. So a 20-liter cylinder contains 6 atmospheres of a gas at 27 degrees Celsius. So what will the pressure of the gas be if the gas was heated to 77 degrees Celsius?
To solve the problem, just work through the following steps. The cylinder volume remains unchanged while the gas is heated, so Gay-Lussac's law gas applies. So Gay-Lussac's law can be expressed as P1 over T1 is equal to T2 over T2.
Where P1 is equal to initial pressure, T1 is equal to initial temperature, T2 is equal to final pressure, and T2 is equal to final temperature.
Now we are going to use the equation or formula of Gay-Lussac's law, which is the P1 over T1 is equal to P2 over T2. So we have an initial pressure before the change. So our P1 is going to be 6 atmosphere. Our initial temperature is 27 degrees Celsius. We need to find or solve the final pressure. Our second or final temperature is going to be 77 degrees Celsius. So whenever we use the gases, we need to convert this to Kelvin. And we do that here by taking the Celsius temperature, 27 and 77 degrees Celsius, and adding 273 Kelvin. So in our T1, we have 27 degrees Celsius. So add the 273 Kelvin. So now we have 300 Kelvin. So in our T2, we have 77 degrees Celsius and add the 273 Kelvin. So now we have 350 Kelvin. So let us proceed to rearranging this equation to get P2 by itself. So first thing you need to do to get T2 by itself is get T2 here out of the denominator, and we are going to do that by multiplying both sides by T2. So now we have T2 on bottom and to the top, so they both cancel out. So now we have T2 times P1 over T1 is equal to P2. So P2 is equal to T2 times P1 over T1. So P2 is equal to 350 Kelvin times 6 atmosphere over 300 Kelvin. So 350 times 6 atmosphere divided by 300 is equal to 7 atmosphere. So our final pressure is 7 atmosphere.